Alright, this is the problem that we just did for the x versus t graph. So if you haven't seen that video, make sure and stop and watch that one in order to know what's going on. And we're going to show you how to make the v versus t graph and then the a versus t graph as well. At the end of this video, I'll also show you how to go the opposite direction. If you decide that a versus t is easiest first, then that's what we'll do, and then you'll see that this one still is what ends up on the very end. In our situation here, we have Blue, which I've made him blue for this video, walks from Pallet Town to some spot. Once he was at that spot, he thought he forgot some Pokeballs, so he stopped for a moment to think about it, and so he headed back to town. And then he realized at this point that he actually did have them, and so he stopped again. Now we started time right before he began moving, and we ended time right when he stopped, after he stopped moving. So this is him picking up speed at the very beginning, accelerating to a constant velocity as he walked. As we discussed in the last video, this should be much, much longer, because of course the much, much longer time that he would be at a constant velocity. And then this small section is when he's slowing down right over here. This is when he's paused at that area for that amount of time. He sped back up going the other way right here, because he's going in the negative direction now. He started a constant velocity for this time segment right here. And then finally, right here at the very end, before he stopped, he accelerated to a zero velocity. All right, now we're going to look at the velocity versus time. This does not do the same thing as the x versus t. You will not see position. On this graph, we know that slope is equal to velocity, because it's change in x over change in t. You'll notice on this graph, the change in y is change in velocity, and the change in x is change in t. So on this graph, right over here, slope will be equal to acceleration. All right. So whatever we see slope doing on this graph, we should then see our y value do right here. So at the beginning of this, he's starting off at rest, which means that he should have a zero slope. On this graph here, it means that we should start at this location right here, because that's zero. For the first time segment, he picks up speed to some velocity here, so there we go. The reason that's linear is because he picks up velocity at a constant rate. Then he hits a constant slope, constant velocity. So a constant velocity on this graph should just be a straight line straight across here in that time segment. During the next small time segment here, he is going to slow from a positive value, which is right up here, to zero. So we go from some positive value here down to zero, again linearly. For this time segment here, we know he stopped, our velocity is zero. So I'll just keep this right on the zero because his velocity is zero here. Here he goes from 0 to a negative value. So I'll go from 0 down to a negative value here. It starts at a negative constant velocity, so it stays constant. And then here it goes from a negative velocity to a 0. So that is what the v versus t looks like for this. Again, if you watch what's happening to slope for each small time segment, and you pay very close attention to this, you will see each section here. Now I'm going to show you a versus t. Now, a, as we've already commented here in class, is acceleration. And we've also pointed out acceleration is always going to be constant. Constants on graphs are always straight lines. So all we really have to do for the a versus t is just figure out, number one, is it on, so is it not 0 or is it 0? And number two, is it positive or negative? In this time segment right here, you can see acceleration, the slope is positive. We can also see here that it's accelerating. So I'm going to start with an acceleration for that time segment. For this longer time segment here, we know that velocity is constant or acceleration is 0. So I'm going to draw for that time segment it right here on 0. So it's right there on 0. You'll notice that they're disconnected here. So we're actually going to draw a line straight down. The only thing that vertical line represents is that it has changed from right here down to 0, and it's done that instantaneously. For the next segment here, acceleration is negative because I've gone from a positive value down to 0. So I'm going to again draw that small time segment here. I'm going to draw a negative value and connect it. And then for the next time segment, again I have a constant velocity, 0. And so that means my acceleration is also 0 for that time segment. For the next time segment, I'm kind of getting a little bit off here. I have another negative acceleration, which we can see from the slope here. We can also see, because this went from a 0 velocity to negative, or further negative. So again, for that time segment, we should have another negative. Now I have another constant velocity, which means my acceleration goes back to 0. And then finally, I have a positive acceleration. There we go. That's how you find the acceleration versus time graph using the velocity versus time graph and then using the position versus time graph. Now what we're going to do is we're going to go the opposite direction. I'm going to show you, using the same example, how you can start to find the acceleration to begin with and then go the other way. Some people find this way easier. Alright, so going the opposite direction now, we're going to start with the acceleration versus time graph. If you struggle seeing it the other way, try it this way instead and see if this doesn't help. So now what you want to do is you ask, is it accelerating? In what way is it accelerating at the very beginning? So you kind of start off with the easier one here because you're just trying to figure out whether or not it's on or off. In this first time segment here that he gets going, he's got to accelerate in order to get up to speed. He's got to go a positive direction, so we know he's going to have a positive acceleration. For most of the time there, he's going to stay at a constant velocity though, so he knows he's going to drop down to a 0 acceleration. It's going to be for a fair amount of time here. So this right here represents when you first got going right in here. This time, which should be longer again, is going to represent from here all the way over here. At this spot in time, he's got to have a negative acceleration to get back to 0. So he's going to drop down and go here for that time segment. And then while he was stopped, he didn't have any acceleration at all. So he should have a 0 acceleration. Then he's going to pick up speed again, but he's going to pick up speed in the negative direction. So again, he's going to accelerate negatively here. And then he stayed at a constant velocity for this segment here. So right in here, he just negatively accelerated. Here he had a constant velocity. So that means for that time segment, he goes back to a 0 acceleration. And then right there at the end, he should have a positive acceleration. Alright, I put some times on here to help you kind of see where we're talking about. Here's T1, T2, T3, and T4 at this spot here. T5 is after he picks up speed again, right in there. T6 is right when he's about to slow down in speed. So if you want to pause it and kind of compare the acceleration graph to this, that might help. Now we're going to take the acceleration graph and go backwards again. Let's go to velocity versus time. Now as we've got over here, we've got some kind of cheat sheet here. Velocity versus time, that's my slope for acceleration. So all I got to do here is I see, alright, I have an acceleration, it's positive, which means it should be going up, positive slope. Then here I have a 0 acceleration, which tells me my slope or acceleration should be 0 or staying at a constant velocity. This point in time shows me that it should be negative. And I know that of course it's going to stop, so that's going to help me to show that it's going to go down, and it's going to go down to 0 during this time. I haven't matched this up perfectly. I'll put the T1s up here in a second. It doesn't accelerate, which means that it stays at 0 because it's not going to change for that time segment. Here it's going to negative accelerate again, so it's going to have a negative velocity. Again, going to have a 0 acceleration during this time. So that means the velocity doesn't change. And finally, I have a positive acceleration, which tells me that this should be going back to 0. And there you go, there are your times again, so that you can match those up with right above it. And finally, we have our x versus t. For x versus t, you can see that velocity is slowly increasing, starting at 0. We're going to start right here, of course, because we know they're starting at position 0. So velocity should start from kind of a horizontal here and go up to a curve. And then slope should stay the same value, or a constant velocity. And slope should decrease back to 0 according to this right here. Slope should stay at 0. Then slope should decrease to some negative right in here. Right in here it should stay at that negative. And then here it should increase, I should say, or a positive acceleration from negative to 0. So you'll notice this is going backwards, going from acceleration back to velocity, back to position. And I moved this around real quick so it's a little bit easier to see, as well as putting the T1, T3, all those on there. So again, if you want to pause this, if you're struggling with this, pause this and notice what went on at these times and compare it to what happened on these graphs. And that should give you, or that should help you out quite a bit in being able to do these for yourself.